Okay, so let's quickly calculate r prime of t, unit tangent vector, etc. Now I say quickly, we can quickly get r prime of t. The process will kind of bog down as we go, but let's just do this as an example. So that I'm not going to explain all the details. It's very clear that the derivative of this function, and since I'm using capital R, I should have made that a capital R, that r prime is going to be equal to the derivative of the I component, and that's going to be 9 times -3. Well, I'm not going to do the details. That's 27 times the cosine of 9t I plus 63 times negative sine of 9t j plus 2t k. So that's -27 cosine of 9t I minus 63 sine of 9t j plus 2t k. Our unit tangent vector is just r prime of t divided by the magnitude of r prime of t. And this is not too bad, although in the process of writing this down, we'll probably begin to have a little premonition about taking its derivative in order to get the unit normal vector. But the derivative, the r prime is just what we have here, -27 cosine of 9t I minus 63 sine of 9t j plus 2t k divided by what we get from the Pythagorean theorem, which is 27 cosine of 9t quantity squared plus 63 sine of 9t quantity squared plus 4t squared. And I haven't written down the negative signs in here. If I wanted to, I could, but in the squaring process, those negative signs are going to go away. Maybe just to be complete, I'll go ahead and write them in. Okay, so we have our expression for the unit tangent vector, just dividing the derivative by its magnitude. In order to get the unit normal vector, all we have to do is take the derivative of this and divide by its magnitude. Now, of course, the derivative of this function is going to be kind of messy, and the expression for the magnitude will be straightforward, but it'll also be messy.